All right, guys, Mr. Jones back here with you. We're going to be still talking about polynomials. Now we're dealing with, basically it's just a fancy name for distribution. We're going to talk a little bit about distribution, but specifically relating to polynomials, we're talking about multiplying monomials, which is a word that means just a single term times polynomials, or our word that means a group of terms, okay? So a single term times a group, that's what we're doing here today, okay? Um, and so just talking about distribution, just reviewing this, okay, we've talked about this before, right? So we've talked about how, right, when we have a number multiplied by a group, what happens to that is it is distributed or multiplied to every term that is in that group, right? So we could say that is 9 times 2x, and then also 9 times this negative 3, right? So we could say that, and then we actually do the multiplication, 9 times 2x. Now, just one thing with this. I know we talked in the last video about like adding and subtracting polynomials, and we said that, oh, you can't combine like term, or you can only combine like terms, and they have the same variable, same index. Now, that's true for adding and subtracting, okay? With multiplying and dividing, it takes a little bit less for you to be able to multiply and divide, okay? Because remember, this 2x, right, how is this connected? This is connected with multiplication right here too, right? This is saying 2 times the x number, right? And so what we're doing is we're basically like adding in another number in the front of that. So now this is saying 9 times 2 times x, okay? So we can basically multiply the two numbers together and then keep the variable at the end of it, okay? So we would do 9 times 2 is 18, and then x, so 18x, and then this is 9 times negative 3, or you could think minus 9 times 3. Either way, you get negative 27, okay? So 18x minus 27 is what you would get after you would distribute that 9 there. So we talked a bunch about that, right? Just multiplying a single number times a group, right? But now what we're getting into is when we multiply like a whole a variable term across a group, right? We see a bunch of those here. What happens when we multiply a variable? It's not that different. It just means we're going to have to apply some of our exponent rules that we learned at the beginning of Unit 5. We're going to have to apply those multiplication exponent rules to this, right? And you remember what that rule says. That rule says we multiply the big numbers, right? The coefficients, we multiply those. Then we add the little numbers. You add the exponents together, right? And so that's going to be important for us as we do this distribution. So here, this is saying 2x distributed, right? So 2x times 6x, right? So if I just have that, 2x times 6x, okay? Again, and you remember, you might not see exponents on these, but it's always helpful to write in. They have a 1 exponent, right? That's kind of the standard exponent on just a single x, okay? So I multiply the big numbers. 2 times 6 is 12. X to the first times x to the first, right? And I would add these exponents. So 1 plus 1 would be 2. So when I multiply 2x times 6x, I get 12x squared, right? And that makes sense. 2 times 6 is 12. X times x is x squared. So it's just kind of putting those together. And then my second term here, I have 2x times this negative 5, okay? Same idea as up here, right? I have a variable term with a coefficient times this other number, so I can still multiply these. I just multiply the two numbers together. So it would be 2 times negative 5 is negative 10, and then with the x at the end, okay? So this is what I would have, 12x squared minus 10x, okay? So that's that one, just one more with a little bit of a bigger variable distributed to a bigger group. This has 3 terms, right? And again, you know it has 3 terms because the terms are separated with these pluses and minuses, right? So that's how we know the terms are separate. So again, we multiply this x squared across these 3, right? And notice this has a 1. You could write in the 1 coefficient here, but basically it just means we're going to be just multiplying by the x's, which means the coefficients here, or the numbers, are going to stay the same, okay? So basically, this is going to be 1x squared times 5x squared. So again, 1 times 5 is just 5. And then x squared times x squared, again, adding those exponents, 2 plus 2 is 4. So that first multiplication results in 5x to the 4th power, okay? This next one, 1x squared times negative 1x. So I notice I added my 1 coefficient. And it has a 1 exponent too, right? It's not showing those, but they're there. Okay, so 1 times negative 1 is negative 1. Again, coefficient stays the same. And then x squared times x to the first, adding those exponents, 2 plus 1 x to the third. And then lastly, x squared times 11. Notice this 11 doesn't really have a variable, okay? So you can still think, okay, 1 times 11 is positive 11, and then x squared times nothing. Basically, you just put the x squared at the end of it, okay? So that's that, okay? You see, so it's just adding a little bit extra with our distribution, kind of having to worry about the variable part as well as the number that you're distributing. So it's just a little bit extra, but the same concept as the distributing we've talked about before, okay? Just 3 bigger examples, and then we're all set, okay? So again, same type of thinking here, right? You're distributing 3x to all the terms in the group, okay? So you can think, okay, big number times big number, 3 times 5, 15. And then exponent, little number. Notice I added in my 1 coefficient, or my 1 exponent, excuse me. So x to the first times x squared, add those. 2 plus 1 is 3. So 15 x to the third is that first one. My second one, 3 times positive 7 would be positive 21. And then x to the first times x to the first would be x squared, right? Adding 1 plus 1. And then 3x times negative 1, so 3 times negative 1 would be negative 3, and then x times nothing. So you just put the x on the end. So hopefully you're starting to get the hang of it here. Now I have ones that are a little bit more complex down here, right? Because these ones include multiple types of variables in there. So just a little bit extra to worry about, but the same process. Okay, you just have another letter to worry about in each term. Okay. So for number 2 here, again, these are, it says xy. So xy is kind of like just a term with 2 letters to it. So xy, and again, it doesn't show it either, but you think x to the first, y to the first. Okay. So xy times x squared y squared plus x to the first. Again, doesn't show it, but add in that 1 exponent, then minus y also to the first. So let's go through it. Again, so we're going to be able to multiply our like bases together. So x with x, y with y. So x to the first times x squared. Again, adding those exponents. So x to the first times x squared would be x to the third. And then also in that term, y to the first times y squared would be y to the third. Okay, so when I multiply this term times this term, I get this. Okay, now my second multiplication, x1, y1, or x to the first, y to the first, times x to the first. Okay, so again, just breaking this down, x to the first times x to the first, x squared, right? Adding those exponents. But then y to the first, there's no y part to this term, right? So I just kind of put that y at the end. Or again, you could write y to the first. You just put that on the end, okay? So that's there. And then the last one, x to the first times negative. Again, this is negative, so we're going to keep that sign the same. There's no number that we're multiplying by, so we'll keep that like it is. So x to the first times nothing. So that's going to stay x to the first, right? Because there's no x part to that term. And then y to the first times y to the first would be y squared, okay? And now you look at this, and something you always want to look for after you multiply something like this, right? Because this is a polynomial, and just like with adding and subtracting polynomials, what we want to look for is, oh, are there any like terms that I can combine to simplify this, to make it a smaller group? And again, you think about, okay, what do I need for like terms? I needed to have, right, do your checklist from last time. Same variable, same exponent, right? And that has to be across each term. So what's weird with this one is each of these have the same variables. They all have an x part and a y part to it, right? But then you look at the exponents, right? The exponents have to match exactly for you to be able to combine. Okay, so 3 and 3. So I would need it to be 3 and 3 for these exponents as well to be able to combine. No, so that one can't combine, obviously. But these two are really close, right? X squared, y to the first, x to the first, y squared. So you might think, oh, 2 and 1, I can combine that too, right? No, if this one was also 2 and 1, I could combine. But they have to be the exact same, and they're just a little different. So no, I can't simplify this anymore. But it's always good to check to see if you can. Okay. Now this last one, number 3, a little bit trickier, kind of bringing it all together, okay? So I have -7, a to the first, b to the first. Again, not showing those one exponents, but they're there, right? And then multiplying that across these 3 terms, okay? And keep in mind, there's a coefficient to this one, so I'm going to multiply the big numbers as well. So I would have -7 times 6 is -42. And then I would have a to the first times a squared, right? Adding those exponents, a to the third, right? And then b to the first times nothing stays just b to the first. Okay, so that is my first multiplication. Okay, my second multiplication, -7, this is a -4. Okay, so I think -7 times -4 is positive 28, right? Negative times negative is a positive. That rule still exists, right? And then I'm doing, right, both of these have one exponents as well. So a to the first times a to the first, a squared, b to the first times b to the first, b squared. Okay, so that's my second multiplication. And then my last multiplication here, -7 times +9. So -7 times 9, you might have to think about that one for a little bit, but it ends up being -63. Okay, and then a to the first, this doesn't have an a part, right? So this just stays the same, a to the first. And then b to the first, this has a b squared. Add those exponents, b to the first times b squared, b to the third. Okay, and then also you could do a quick check, and I kind of spoiled the surprise there, but there's no like terms, but it's good to check as well. All right, guys, so there is a little taste of distributing these monomial, these single terms with variables to a group, okay? So I hope that makes sense. We'll get into some more multiplying and distributing here in another video, so stay tuned. But thanks for following.